the relationship between acceleration due to gravity, which is G. This acceleration due to gravity, which is G, is still the same thing as gravitational field intensity. It's still the same thing as what? Gravitational field intensity. So we want to discuss acceleration due to gravity and what? And gravitational force. What is the relationship between them? Okay. Now, if you have F, which is equal to, this is gravitational force, right? Which is equal to what? G M1 M2 divided by what? R squared. That FG is equal to what? M times what? Times G. This one is a function of this one. The force of gravity experienced, okay, is a function of what? Acceleration due to what? Due to gravity. Why this M, irrespective of the location, is usually what? Constant. Is usually what? Constant. Either you are in planet 1, or you are in planet 2, or you are in planet Earth, or you are in planet Mars. Mass is always the same. Okay? Mass is always what? Always the same. Now, but you see this G. This G, which is acceleration due to what? Acceleration due to gravity. Okay? Determines the what? The force of what? The force of gravity. If the acceleration due to gravity is very high, okay, that means the force experienced by what? By the object will be what? Will be high. If the acceleration due to gravity of a particular place is very low, okay, the force of gravity in that place will be what? Will be very low. Okay? Now, if you now have an object, you have what? An object within the surface of the earth or within the earth. What it means is that you have an object, okay, and what? And the earth. You have what? An object and what? And the earth. So if you have mg to be equal to what? Gm, mass of the object and mass of the what? Mass of the earth. Because we are now comparing what? Mass of the object, mass of an object and mass of the what? Earth. Divided by what? The distance between them. Now this Fg is equal to what? Mass of the object multiplied by what? Acceleration due to gravity of the what? Of the object or of Earth. Of Earth. Which is equal to what? G M E divided by what? R squared. So mass of the object will cancel the what? Mass of the what? Mass of the object. So your G will now be equal to what? G M E all over what? All over R squared. So you can have G to be equal to what? G M E all over R squared. So that is another relationship between what? Between acceleration due to gravity and mass of the earth. Or you say acceleration due to gravity and distance between them, and acceleration due to gravity and what? Gravitational what? Constant. Is equal to what? Mg. You can say what? G is equal to what? F all over what? F all over M. You can have what? G to be equal to what? F all over M. That's another relationship between what? Between them. Gravitational field intensity or acceleration due to gravity, they are all what? They are all the same. What? Given F. F is given to be what? F, example. F is given to be what? 40 Newton, right? What again are you given? Mass of the object is what? 4 kg. And you have to find what? Gravitational field intensity. Since F is equal to what? Mg, G is equal to what? F over M. What's your F? 40. What's your M? 4. 40 divided by 4 will give you what? 10. What's the unit of G? Meter per second squared. What could also be the unit? Newton per kilogram, right? Which is what? 10 Newton per what? Per kilogram. Do you understand what I did? This is what? 10 Newton. This is Newton and this is kilogram. 10 Newton per kilogram. The mass and weight of a body on Earth are 8 kilogram and 80 Newton respectively. Determine the mass and weight of the body respectively on a planet where the pull of gravity is 1 over 8 that on Earth. Is 1 over 8 that on Earth. This question is relating a particular object. Look at it very well. It's relating a particular what? A particular object within the Earth. And when that same object now is now placed on another what? On another planet. Do you understand? Okay, within the Earth and on another what? Another planet. And on the what? On the Earth, we have been given that its mass is what? 8 kilogram. Okay? And its weight is what? 80 Newton. Okay? 80 Newton. That is on the what? On the Earth. They now say determine the mass and weight of the body, respectively on the planet, where the pull of gravity is 1 over 8 that on what? That on Earth. You know, definitely, acceleration due to gravity is what? On the Earth could be different from another what? Another planet. What they are now saying is that acceleration due to gravity of a particular planet, we don't know the planet, is now what? 1 over 8 that on the what? On the Earth. Do you understand? Do you understand? That last statement, that acceleration due to gravity of the what? Of a planet is 1 over 8 that on the what? That on the Earth. So meaning that acceleration due to gravity of the planet is 1 over 8 that of what? Acceleration due to gravity of the what? Of the Earth. So we are now to get the what? Weight of the what? Of the planet and what? We have to get the what? We have to get the mass and weight of the body respectively on the planet. Weight of the what? Of the body on the planet and mass of the what? Of the body on the same planet. So that's what we have to what? What we have to find. Now, what are we going to do? Okay? If you have, this is on Earth, right? Okay? From here, you can have F to be equal to what? Mg, right? If you are dealing with what? You are dealing with what? Earth. F is equal to what? Mg. What is the force? It is still the same thing as what? Weight. That means your weight is equal to what? Mg of the what? Of the Earth. And also what? Mass on the what? On the Earth. This is not mass of the Earth though. Mass on the what? On the Earth. Mass of the body on the Earth. And acceleration due to gravity of the what? Of the Earth. Or let me put it like this. Mass of the body on the what? Earth. And this is the acceleration due to gravity of the what? Of the Earth. Okay? What is your weight? 80. Your weight is what? 80. What is the mass of the object? 8. Is what? 8. And what is the acceleration due to gravity of the Earth? 1 over 8. Is what? 1 over 8. This is of the planet equal to 1 over 8 of GE. What is GE? GE is constant. Even if you put it, what's your weight? Your weight is what? 80. What's your this? 8 multiplied by what? GE. So G is equal to what? 80 divided by what? 80 divided by what? 8, which is equal to what? 10 what? 10 meter per second square. 10 meter per second what? 10 meter per second square. That is what? Acceleration due to gravity on the what? On the earth. Now, but when we get to the another planet, okay, acceleration due to gravity on another planet is what? 1/8 that on the what? On the earth, which will now be what? 1/8 multiplied by what? 10, which will give you what? 1.2 meter per second square. You said what? 1.225. 1.25. 1.25 meter per second square. Are we following?
Yes, sir.
This is acceleration due to gravity on the earth, which is this. Now, acceleration due to gravity on another planet is what? Is this, based on this relationship. Based on this what? Relationship. Now, but what we have to find is what? Weight and mass on another what? On another planet. Mass and what? Mass and what? Weight on another planet. What will be the mass of the object on another planet? Who can tell us? What will be the mass of the object on another planet? Mass of the body on another planet. What will it be? What will it be? There's one thing I told you from the beginning of the class, that mass of the object does not change irrespective of the what? Of the location. Once we have estimated the mass of an object to be a particular value, anywhere it goes, it will assume the same value. So meaning that mass of the object on another planet will also be equal to what? 8 kilogram. You have what? 8 kilogram. So the only thing that will change is not the weight that will change. It's not the what? It's not the weight that what? That will change. Now you still use the same formula where you have weight, which is equal to what? Mg, right? But this one is now for what? It's for planet. This one is also what? For planet. That means we want to know weight of the object on another what? Planet. It's now equal to what? Mass of the object in that planet, which is still the same thing as what? 8 multiplied by what is the acceleration due to gravity of that planet? 1.25. Now 8 multiplied by 1.25 will give you what? 10? 10. It will give us what? 10 what? 10 what?